All right, 11-2, 11-3, we're going to combine these assignments into one day because both are relatively short. So for 11-2, we're going to talk about congruent triangles. And just as a definition here for what congruent triangles are, okay, it means same measurement for angles and sides. So for them to be considered congruent triangles, all the angles have to be congruent and all the sides have to be congruent. Okay. All right. So if we are given, we're not given a picture, we're just given it like this right here. Okay. This tells us that triangle, that's what that triangle symbol means. Triangle CMH is congruent to APL. Okay. And if that's the case, that means all the sides are congruent and it means all of the angles are congruent. So, and then likewise, we've got triangle DNO is congruent to AET. So that's a second set of congruent triangles. So it wants to know what angle right here, what angle is congruent to angle M? Well, what you have to do is you have to find angle M. It's the middle angle. So find the middle angle in the other one. So it's congruent to angle L. And I'm just going to kind of keep it flow a little bit better. I'm going to skip around. I'm going to do all the angles first. Then I'm going to go back and talk about the way you do the sides. Okay. That way we're not jumping around. So number 6, angle C. Well, let's find angle C. Angle C is right here. It is the first in the triangle. So that means it's congruent with the first in the other one. So angle C is congruent with angle P. Pretty easy. Do we need to do any more angle ones? I think we're pretty good on that, right? Angle ones are easiest of all. All right, now let's look at line congruency. And I actually want to do number 3 first, and then I'll kind of circle back to another one. But if we look at, and I'm going to erase, if I can, erase a little bit of this just to kind of unclutter some of what I'm doing here. All right, so if we have line DN, okay, line DN. Line DN is right here. Line DN is the first 2 in the first triangle, which means it is congruent with line AE. Yes. Oh, so that means line DN is congruent with line AE. Okay. Now, the reason I wanted to skip MC is because I want to show you this. Okay. If we look at line MC, notice that it is congruent to, here's line MC. It's the first 2 in the first triangle. So I'm going to put a line over the first 2 in the other triangle. But what I want you to notice here is that it's not CM, it's MC. So since you read it backwards here, you would put it backwards here too. So MC would be congruent with LP. So I'll give you a second to get that written down in your notes. All right. So the main thing I wanted to point out is if it's written middle point, then first point in the first triangle, you want to list it middle point, first point in the second triangle, because you always want things to be identically congruent. Okay. So let's look at TE. Okay, this is another good example here. Let's see if I can, oops. All right, so if we look at number 7 here in our examples, it says line TE. Well, let's find line TE. It's right here. Right, there's line TE. It's the middle and the second. So I'm going to also put a line over the middle and the second here. But it's T and then E, so it's the last and then the middle. So for my answer, it would be line what? O and then N, okay? Because we always want to list it in the order that it is congruent, or with the other one that it's congruent with. Okay, makes sense? So if you want to really quickly, just take a second and figure out FL. So find FL, which is right here. Okay, there's FL right there. It's the last two. So I'm going to put a line over the last two here. And then make sure you list it in the right order. It's last middle. So I would put last middle. Make sense? Okay, that part's done. Now let's go to find the value of X for each pair of congruent triangles. Well, what do I know about congruent triangles is they have the exact same side lengths and the exact same angles. So all I have to do, and it really is this easy. I want to find X, right? I want to find the value of X. So I need to find the side on the other triangle that is congruent, which means you got to use your angle markings here. So X, notice X is between the 2/ and the 3/, right? So go to the other, and then I'm going to highlight that side just so I know. That's the 2/ and the 3/. Well, go to the other triangle and find the side that is between the 2/ and the 3/ angle, and it's right here. Once you have them identified as congruent sides, well, then X equals 16 is pretty easy. So when I say the hardest part, and I really use the word hardest very loosely here, the hardest part is just making sure that you're identifying the right sides as congruent. And you just use the markings, either the side or the angle markings. You use that to kind of whittle down what's congruent. So let's look at number 10. We want to find X, and we know that X is between the single and the triple. So I'm going to find the single and the triple in the other one. And I'm going to highlight the same line that is between the single and the triple. So that tells me that those two lines are congruent. And once I know that information, identifying X is very easy. Okay, let's do one more quick one. Actually, if you want to do this one really quickly, and then we'll do it together. All right, so X, it's between the double and the triple. So on the other triangle, I find the double and the triple, I highlight it, and that tells me that X equals 10, okay? All right, for number 12, it says, what is the value of X? Now this takes a little bit of algebra, and that's okay, because you guys know, I remember when I told you at the beginning of the year when we were solving equations, I said this doesn't go away ever. It really doesn't, it keeps coming back. So we wanna solve for the value of X, and X is right here. And X, it's that side length, which is the triple slash, it's 4X plus 8. So let's find the triple slash on this side. And what does it tell us about the length of that side? What's it equal? 20. So we know that 4X plus 8 has to equal 20 because it has to equal the other congruent triangle. So then over here, we've got 4X plus 8 equals 20. Well, now we got to solve it. And we've been doing this for months now, right? We're going to subtract 8 from both sides. That gives us 4X equals 12. We're going to divide by 4 and divide by 4. And we get that X equals 3. So we found the value of X, which was the instructions, by using the congruent triangles and a little bit of algebra. Okay? All right, so let's jump ahead to this section, and your homework is going to be exactly like this as far as the directions. So let's look at that first. Determine whether the triangles are congruent. That's step 1. So you're going to have a yes or a no. Okay. Then if they're congruent, it goes on to give you a little bit more instruction. If they are congruent, name the corresponding parts, so angles and sides, and write a congruent statement. And I'm going to show you here in a second what a congruent statement is. It's super easy to write. Okay. So let's look at number 13. First of all, yes or no, is it congruent? What do you guys think? Matching sides, matching angles, all match up perfectly? No. So it's not congruent. So since my answer is no, it's just no, and I'm done. Now let's look at 14. we've got a 1/, 2/, 3/, 1, 2, 3 in the angles and on the sides. So does that tell us that all three angles and all three sides are the exact same? So would this bin be congruent? Yes. All right. Since we answer yes, we have to first list or name all the corresponding parts. We're going to start with angles. Angle T is congruent with which angle on the other one? Yeah, it equal W because those are both the 1/ angles. Let's go to the 2/ angle. So angle U would be congruent with what? With what? X, yeah. And then let's go to the 3/ angle. And so we have angle V is congruent with angle what? Y. Okay, that's the angles. Now let's list the congruent sides. Okay, so the first side, and I'm going to try to do this a little color coordinated here. I'm going to do TU, which is the 1 angle slash and the 2 angle slash. So I'm going to go ahead and highlight the 1 angle slash and the 2 angle slash over here, right? Those are the two that are congruent, but I want to make sure I list it in the right order. So I'm going to do 1 angle slash first. So that tells me that TU is how I'm going to list that side. And I went 1 angle to 2 angle. I went T to U. So I'm going to say that's congruent to, well, I want to use the 1 angle first, which is W, and then the 2 angle second, because I want to keep them in the right order. Now I'm going to do 2 angle to 3 angle, all right? 2 angle to 3 angle. So 2 angle to 3 angle, that's this side. And of course, on your homework, you are always more than welcome to do whatever color coding you want if it makes it easier. So if I do 2 angle to 3 angle over here, that would be UV, right? On the other one, if I do 2 angle to 3 angle, that would be XY. I got to make sure I keep it in the right order. I can't do YX because that's messing up the order of the congruency. Does that make sense? Am I keeping y'all there? And then last, I'm going to do 1 angle to 3 angle. So 1 angle to 3 angle. And when I do that, I'm going to do 1 to 3, which would be TV. So that means on the other one, I'm going to do 1 angle to 3 angle, which means I'm going to put what first? Yeah, the W, then the Y. So here I have listed all of the corresponding parts or the congruent parts. I've listed angles and I've listed sides. The last step is this step right here, where it says write a congruent statement. The congruent statement is extremely easy. Okay, here's your congruent statement. And I'll go ahead and I'll just put congruent statement so you know that that's what this part of it is. The congruent statement is saying that triangle, and I'm going to list TUV in order of first, second, third striped angle. Does that make sense? So I'm going to label this triangle TUV, right? I went first stripe, second stripe, third stripe. So that means when I label the other one, okay, when I label the other one, I'm going to move that over a little bit. I'm also going to go first stripe, second stripe, third stripe. So that means that I'm going to do triangle W, second stripe X, third stripe Y. So I keep everything in the same order. So this part right here is me naming, I'm going to put congruent, the congruent parts. And then this part here is writing the congruent statement. Okay, sound good? Easy enough? All right, that's all on that side. We're not doing that bottom part. So go ahead and flip to the other side and we're going to talk about rotations. Now, these are the part I'm going to use a visual because I am a very visual person. Okay, so I have got a triangle here labeled very similar to the one on your paper. So I've got corner A, corner B, corner C up here, right? Kind of similar. What a rotation means, and it depends on what you are rotating it on. And I do want you to put one thing in your notes, I guess, even before we get started, is when it says that it rotates about point A, that point A is called the center of rotation. And you can pick a lot of things. It can rotate around point A, point B, point C. It can rotate around an origin. There's a lot of different things here where it can rotate. But in this particular problem, it tells us that it rotates around point A. The other thing I want you to put in your notes is just a little graphic up here to remind yourself. And I kind of think of it almost like a clock. 90 degrees is like 3 o'clock on a clock, right? 180 degrees, if this is your origin, if this is your start point, 180 degrees is like going around to the 6 or moving around clockwise twice. And then 270 degrees is moving 3 times around, or 3 90-degree rotations. And this is all moving clockwise. And you can also move counterclockwise, but we're going to talk about clockwise first. So if you look at number 1, it says rotate 270 degrees clockwise around point A. So that means point A is your fixed point. Okay. So when you move this around point A, notice right now, this line is pointing to the 3. So if we're going to move it, and I'm talking about a clock, if we're going to move it 90 degrees, that means we need to go from the 3 down to the 6. So that is a 90-degree rotation about point A, right? Rotating around point A. Well, now we want to do 270. So we need to do that 2 more times. So now we're pointing down to the 6. Now we want to spin it around till it's pointing to the 9 on a clock. And we need 1 more rotation because we need 270, which is 3 sections. So we need to spin this 1 more time to where this line is pointing up to the 12. So remember, our original AB was pointing to the 3, and we are now 3 movements around the clock pointing to the 12. So when we go to reproduce this, we're going to draw the triangle. Notice our A is down here still, and we're going to call that A1. Now B is above or straight up from A1, so that's my B1. And then my C is now out to the side, so over here would be my C1. And so that is what my image looks like, rotated 270 degrees around the clock. Does that make sense? Clockwise. Now, the other thing I want to show you real quick is that if I go 270 degrees clockwise, is that the same as going 90 degrees counterclockwise? 270 is 3 ticks around this way, right? Would this counterclockwise 90 degrees, would that be the same as going the other way 270? It is. It should look like what you just drew on your paper. Okay. Now, if you ever do anything 180 degrees, it flips exactly upside down, because I think about if you do a 180, have you ever heard somebody say, man, that person did a 180? What does that mean? It means they turned around and went right back the exact opposite direction. So that's what a 180 means. So if you look at number 2, okay, and I don't have a giant shape like this to talk about, but I'll show you how to do it, okay? So what if you don't have a big shape that you can do? Well, 2 things you can do. If you are a very visual person, this is what I did to play around with it to make a key, okay? I would take a scrap piece of paper and I would cut it out this shape, and I would put A, B, and C, and then I would just start turning it until I thought I got to the right turn point, and then I would draw that graphic. But what if you can't do that? What if you don't have paper or whatever? You can't do that. I want to show you how you can actually do it on here. If you do real light strokes with your pencil, they're very easy to erase, and I'll show you what to do lightly. So it says rotate 180 degrees clockwise around point A. So point A is my fixed point. So I'm going to come over here and I'm going to give myself a new point A. Okay. Now, if you can just visualize this in your head, this whole shape is going to spin around point A 180 degrees. So it's basically going to rotate and turn upside down. But I'm going to show you how to do it like on paper so that you can really visualize it. So let's look at how point A and point D right now, currently, right now, you have to go, and I'm going to do this in color-coded dotted lines. Right now, you go this way, right, to get to D. Well, a complete 180, this is the original, right? This would be a 90-degree rotation. So a 180-degree rotation would take point D over here, and that would be your D1. And then again, if you do it really lightly, I would recommend you just erasing this right here on your on your paper so that it kind of is cleaned up a little bit. I'm actually going to leave that because I'm going to print these notes out for somebody. And then let's look at A to B. Okay, so if we do A to B, it originally went down. So this was the original A to B. You have to go a complete 180. Well, think about what that means. What is 180? It makes a straight line, right? So this would be my new one. And if I wanted to add the 90 degree, it would go there. But to go from the dashed purple, do a 180, it means make a straight line. So I can go this way with my solid purple, and that gives me my new B, right? B1. Now I can't really use A for C because they're opposite of each other, but let's look at BC, okay? So from B to C originally went this way, right? So B to C originally went this way. Well, what would 180 do? Make it a straight line the other way. And that would be your new C. And then you would just connect here C to D, and that gives you your new 180 degree rotated shape. So if you can't cut out a piece of paper or find something that looks like your shape in your house and label them A, B, and C, and D and spin them, that's okay. You can actually do the spin on paper. It just takes a little bit of slowing down and a little bit of kind of thought about do the original in dotted lines and then manipulate it however you need to. Yes, sir.
I kind of thought about like taking my paper and like slipping it.
Yes. Yeah. And that's why I said, if you have the opportunity to cut out a shape and actually do what you said, which is put your finger on a corner and spin it 180 degrees or 90 degrees, that's really the easiest way to do it. But if you do that on your paper that you use, go ahead and label your original C, B, D, and A, so that when you spin it, you know where your new C, B, D, and A go. Okay, because they're not always, notice here, my B and C were on the bottom, now they're on the top. My D and A were on the top, now they're on the bottom. So make sure you spin your vertices with you, okay? All right, so that takes us to just one more section right here, and this is quick and easy. Is our figures rotationally symmetrical? And if they are, describe the rotation angle. This is very, very easy. Put a pin right in the middle of your shape and ask yourself, if you spun it, would it look the same no matter which way it stopped? Okay, basically, is it symmetrical? If the answer is yes, then it is symmetrical. It's very easy to find the angle of rotation. I'll show you how. Find points that are identical. So like this point, this point, this point, this point, and this point. Would you all agree that there are 5 identical points on this image? Okay, that means you take 360, divide it by 5, and you get 72, and that's your degrees of rotation. So just literally on your paper, put dots on what you're considering your exact points that are identical. And if there's 2, great. If there's 10, that's fine. And then divide that by 3, or divide 360 by that number. Okay, is number 5, put a pin right in the middle. Can you spin that anyway and get any kind of symmetry? So that would be a no. On your homework, all I want you to do for 3, we're going to actually visit 3 tomorrow. All I want you to do for 3 right now is graph this original image on your homework. I don't want you to worry about doing the rotation around the origin. So on 11.2, do them all. On 11.3, do most of them all, but except for on number 3, skip the rotation part, because I'm going to talk to you tomorrow about how to do that rotation. Okay? All right. For those of you at home, take good notes and then email me if you have any questions.